next topic is iterative data transfer. When programming with loops, such as for loops or while loops, sometimes you want to call data from a previous iteration of the loop. In LabVIEW, shift registers are used to pass values from one loop iteration to the next. Data enters the shift register on the right register and is passed on the next iteration to the left register. To illustrate the use of shift registers in LabVIEW, we can create a simple LabVIEW VI. First, create a numeric control on the front panel and change its value to 2. We can double-click on the numeric control's name and rename it Initial. Next, create a numeric indicator on the front panel. We can name it Result. Now we can change to the block diagram. Just go to Window and Show Block Diagram. Let's place a for loop in between the control and indicator. The for loop is located under Programming and Structures. Click in the top left corner and drag down to create the loop. Now, let's wire the initial control to the edge of the for loop. Right-click on the tunnel we just created and click on Replace with Shift Register. Now, wire the output of the right shift register to the result indicator. Next, let's place a multiply function inside the for loop. Right-click on the block diagram and go to Numeric and Multiply. We can wire the input from the left shift register to the multiply function. We'll also wire the output of the multiply function to the result indicator. Next, right-click on the remaining input of the multiply function and select Create Constant. Let's change this constant's value to 3. Finally, we need to tell the for loop how many times to run. Right-click on the input of the loop count and select Create Constant. Let's run the loop twice. Next, we can step through the code to see the result. The value of initial, which is 2, will come into the loop and will be multiplied by the value of 3. The result will be 6. This will be sent to the right shift register, which will send it to the left shift register at the beginning of the next iteration. Now the value of 6 will be multiplied by 3, resulting in 18. The value of 18 now exits the loop because the loop has run twice. Let's see if this is the case. Switch to the front panel and click Run. The result indicator shows the result of 18. The next section of this tutorial deals with case structures. When programming in LabVIEW, sometimes you want to choose between multiple sections of code based on an input. A case structure does exactly this. Based on the input it receives to the case selector terminal, the case structure will choose which case or section of code to execute. The case selector terminal appears as a small question mark on the left side of the case structure. If you change the input to the case selector terminal, the sections of code that are executed will change. In the following figures, the case selector executes different code for the inputs true and false. The case selector terminal can receive multiple data types. The following data types can be used as inputs to the case selector terminal: integers, Boolean values, strings, and enums. To explore case structures in LabVIEW, I've built a simple LabVIEW VI. I have two numeric controls, which are named Input1 and Input2. Also on the front panel is a numeric indicator named Result. Finally, there's a Boolean push button. I've renamed the Boolean push button Add. The Boolean push button can be found by right-clicking on the block diagram and navigating to Boolean and Push button. Now let's change to the block diagram. Now let's place a case structure between the inputs and result. Just right-click on the block diagram and navigate to Structures and Case Structure. The case structure is placed much like the for loop or the while loop by clicking and dragging. The selector terminal can also be moved by clicking and dragging it. We can now wire the Add Boolean to the case selector. For the true case, this VI will add the inputs. For the false case, it will subtract them. Let's add an addition VI to the true case. Right-click on the block diagram and select Numeric and Add. Now we can wire the inputs for the add function to our input controls. We can also wire the output to the result. In the false case, put a subtract function VI. To select the false case, click on the arrows at the top of the case structure. Now wire the inputs to the subtract case to our input controls. And finally, wire the output to the result indicator. Let's switch back to the front panel and run the VI. First, change our input 1 to 1 and our input 2 to 2. When the Boolean is true, then the result should add 1 and 2. When the Boolean is false, the result should be -1.